Let's just talk a little bit about cubics and some of the common cubics. The perfect expansion for a cubic: a cubed, 3a squared b, 3ab squared, b cubed. You'll notice the powers of a, they're going down by 1, the powers of b, they're going up by 1. At any time you get the two powers, and it should add up to be the power of the, whatever the expression is, in this case 3 for a cube. And that pattern exists for all binomial expansions. The coefficients, or what's known as the binomial coefficients, they're worked out by a thing called, you might have heard of it, Pascal's triangle, I suppose is the first way we look at it. Combinations is another way, which we'll see later on as well. If it's a minus b or cubed, same expansion, difference is the sign is alternating. The negative will occur whenever the second term has an odd power. Because if you think about it, you're saying negative b to the power of something. Well, if it's an even number, that's going to be positive. If it's an odd number, it's going to be negative. So whenever that second term has an odd power, that's when the term should be negative. Okay? Just little ways of keeping check with yourself that you're doing the right expansion. Difference of two cubes, just like we have a difference of two squares formula, we have a difference of two cubes. Starts off with a minus b, just like difference of two squares starts off with a minus b. In the second parentheses now, a squared, ab, b squared. All that's really happening there, again, is to do with the powers. Start off with the first one, power of 2 goes down by 1, the second one goes up by 1. There's a very common mistake that's then made. What do you reckon it is? Yeah, writing 2ab, because we're so used to seeing it. Coefficients in this one are always 1, or negative 1 when we come to this one. Because we also have a sum of two cubes. Sum of two cubes. It starts off with a plus b, and again you'll notice in this one, it's when the second term is odd, we end up with a negative sign. Because what we're really doing here is going a minus negative b to the power of 3. Okay? So that's why it turns out that same pattern. Okay? You can always factorise the sum of 2 if the power is odd. Can't do it when it's even necessarily. So that's why we don't have a sum of 2 squares factorisation. But we do have a sum of 2 cubes. Alright, so 2a minus 5 all cubed. This is the sort of thing you probably just do in your head, but you know, the first term, powers of 3 going down by 1, powers of a going up by 1. Tidying it up, there's our answer. Sum of 2 cubes, because 8 of course is 2 cubed. Again, you're probably thinking that, not necessarily writing it. So x plus 2, x squared minus 2x plus 4. Also difference of 2 cubes, because of course 27, 3 cubed. So y cubed minus 3a all cubed, there it is. So it's about learning the patterns to save time in our factorisation. In fact, there's the generalised formula for any power. So if you are a to the power of n minus b to the power of n, it always starts off with a minus b. Those that were here yesterday, I remember when I did the difference of 2 squares and I said, actually, theoretically, the a minus b should come first. That's why. Because in the general expansion, we start off a minus b, and then it's simply the powers of a going down by 1, the powers of b going up by 1. So if I had to do x to the power of 5 minus y to the power of 5, x minus y, powers of x start at 4, go down by 1, powers of y start at 0 and go up by 1. A to the 7 plus, right, we can do this one because it's an odd power, because I was saying what we're really saying is minus 1 to the power of 7. So we see our expansion, it starts with the a plus 1, but every time the second term has an odd power, I mean it's not there because the second term is 1, but theoretically there is a 1 to the power of 1 there, so that's an odd one. So easier way of just thinking about it is it starts positive and it just alternates, plus minus, plus minus, plus minus, as far as we need to go. Okay, that's enough for me. Now we can give our peer supporters their texts and all that sort of thing. Enjoy.